My name is Omodei. For the past 5 years I've been developing an effective method for watering a garden from a rainwater tank. I'd like to share my knowledge and experience with anyone interested. This video will answer 3 questions. What is the simplest way to water your garden from a rainwater tank? Why is this information not available from any irrigation supplier? And how can the irrigation system be automated using a solar panel? I will now give step-by-step instructions for setting up a simple, low-cost irrigation system. Install a network of 19mm polypipe to deliver water from the rainwater tank to the plants in your garden. Note that hose clamps are not needed. Install an inline filter. Install a number of clear vertical tubes to monitor the water pressure at various locations in the garden. Before installing the emitters, the water level in the vertical tubes will be the same as the water level in the tank. Install emitters to deliver water from the polypipe to the nearby plants in the garden. All emitters should be at approximately the same level. For gravity feed irrigation, an ideal emitter is a short cylindrical tube or nozzle where the diameter of the nozzle is sufficiently small to ensure that water is emitted very slowly. I recommend using short, blunt stainless steel needles. The nozzles are color-coded to indicate their internal diameter. Position a plastic hobby box or similar container at a central location in your garden. Position a yellow nozzle so that it drips water into the box. The nozzle is called a control nozzle. Mark a level line on the inside of the box about 7 centimeters below the overflow level. When the water level is about 1 centimeter below the level line, turn on the tap at the bottom of the rainwater tank. When the water level reaches the level line, turn off the tap. Due to evaporation, the water level will fall, and so the cycle continues indefinitely. The box is called the evaporator.
Provided the pressure is the same at each nozzle, the table shows the average number of litres per week delivered by the 9 different nozzles. The table is based on the annual evaporation and rainfall in Adelaide.
Black, 0.8 litres per week. Green, 1.5 litres per week. Yellow, 2.3 litres per week, etc., all the way through to olive at 28 litres per week. When it is very hot, water evaporates more quickly, and so you will start the next watering sooner. And when it rains, extra water enters the evaporator, and so you will delay the start of the next watering. When you are irrigating your garden, it's a good idea to check the water level in the vertical tubes to ensure that the nozzles are at roughly the same pressure. Why is this information not available from an irrigation supplier? Irrigation companies worldwide have invested billions of dollars in pressurized irrigation. Gravity feed is a potential threat to this investment. Suppose that you walk into a local irrigation supplier and say that you would like to irrigate your garden using a rainwater tank. One of the first issues raised will be the choice of pump, and from that point forward, gravity feed will never be mentioned. If you decide to use gravity feed irrigation, don't expect any support from the irrigation industry. Please share this video with others so that gravity feed irrigation may one day challenge the dominant paradigm of pressurized irrigation. How can the irrigation system be automated using a solar panel? You will need a solar panel, a 12-volt battery, a charge controller, a level sensor, a valve controller, and a solenoid valve. I will now give step-by-step instructions for automating your irrigation system. Install a 10-watt solar panel in a suitable location facing the morning sun. Place the level sensor on the evaporator. When the water in the evaporator falls below the low probe, the valve controller opens the valve and the irrigation commences. When the water level reaches the high probe, the valve controller closes the valve and the irrigation stops. The cycle continues indefinitely. To change the irrigation frequency, adjust the gap between the high probe and the low probe. You need to take account of the local evaporation rate. A change in level of 1 millimetre is equivalent to 110 mils. Measure the control volume. This is the volume of water that drips from the yellow control nozzle into the evaporator to raise the water level from the low probe to the high probe. It is also the volume of water that must evaporate before the next irrigation. The volume of water emitted by an irrigation nozzle is the control volume multiplied by the nozzle ratio of the irrigation nozzle to the yellow control nozzle. For example, if the control volume is 1.5 litres, then the table lists the nozzle ratios and the corresponding emitter volumes. Let me emphasize 3 important points. You decide in advance how much water will be delivered to each plant in your garden and select the nozzle accordingly. The irrigation frequency is controlled by the prevailing weather conditions. When it is very hot, the water evaporates more quickly, and so the irrigation frequency is greater. And when it rains, extra water enters the evaporator, and so the start of the next irrigation is delayed. And last but not least, sunlight and rainwater are free. A lot more detail is available on my website, www.measuredirrigation.com.au. Please don't hesitate to contact me if you have any questions or if you need advice about gravity feed irrigation. Thank you.